Welcome back to 115, another day of coding. Today, what we're going to be talking about is how to take this music rating app and make it safe and secure. So the good news is that we've done a pretty good job of the design of this app. Right? So some of the choices that we have here are completely out of our control, of course. The app itself, right? We're using Ajax because we're running it on two completely different computers, or more than two computers potentially. Replic's computers, which run the code, and the client's computers, which run all of the JavaScript versus the Python. But, the JavaScript code doesn't really need to be secured at all. And in fact, we really can't secure it, right? Anything that we do on the client side is totally open and available to the client, right? They can actually, even if they wanted, I'm going to set a breakpoint here, and they could actually watch our code get executed by, if they know what they're doing, they can set a breakpoint and watch what happens as it goes through and potentially add their own changes to it. So relying on the client, anything in JavaScript, anything on the client side to secure our application is kind of foolish, right? We're relying on the people who we don't trust to not do something bad because we don't trust them. That doesn't make sense, right? So that can never be the issue. And in fact, if we wanted to, and we'll actually talk next week about how we can use like cookies and local storage and session storage. If we tried to do any of this, again, we don't use it in this app right now, but this would be totally open and available for any user out there to modify on their own. So all of the changes that we need for security have to be done on the server side in our Python code. Now, the way that we've actually implemented this, right, the main.py file, its entire job is to work with the bottle library. So all the only code we have in here is to handle those incoming web requests. So, getting files, an Ajax GET request, a couple of 3 Ajax POST requests. And all they really do is, in the sense of the GET requests, they just get the data called json.dumps to turn that Python data into a JSON blob and then return it. In the case of the POST requests, they get the JSON blob that was sent in, convert it to usable Python data, call the appropriate function, get a JSON blob to return back. So that means that any of the changes that we need to secure our application have to be in ratings.py. And now we can start to think about what needs to change for safety. So if you remember at the end of the last live Q&A in today's videos, we showed how just by executing whatever the user types in, that can actually cause problems, that can cause errors. It could cause an error, could cause some embarrassment, or could actually allow them to potentially damage or even modify our program, none of which is good, modify our data. So we need to go through, and anywhere we're using the database, look to see if that's okay. So here we have this first create table query, and of course that's not executing any code that the user typed in, and beyond that, it's also not actually parameterizable, right? There's no parameterized version of that. So this can stay the same. Here we have a select star from songs. So it selects all the songs. again, just a plain old select statement cannot be parameterized. There is no safe version of that because there's nothing that the user has typed in here that could be part of an attack. So we don't have to worry about that one. The next one is all songs by artist, and this is used when we do a search. And now here is where we start to get into trouble, right? Because we have select star from songs tables, that's so far so good, but then we say where artist is equivalent, and then we have whatever name they typed into that search box right here. So this is potentially a way that they could attack the system. And a really good trick to learn, a really good trick to know is, right, since this is going to be a string, we need, if we're using the standard query, the unsafe query, we need to have that string inside of quotation marks. We can actually use single or double, though single is by far more common. Anytime you're using a web app and you see that you cannot use, in CS terms, we usually refer to this as a tick. You can't use that tick. You can't use that single quote. That's telling you that they are not separating out the data, what you're typing in, from the code, the SQL. And that means they can get hacked. Sometimes this can be for your, depends how you look at it, benefit or harm. One example, the job I had before I came to UB, I was a faculty member also at this other institution. And at one point they had a bunch of us faculty in to test this new reporting app. So I had, I was testing it out and they were having us beta it. And so I'm entering in all sorts of things, just trying to see what happens, how it would work. And at one point I enter something in and one of the developers says, oh, no, you can't do that. You can't use a single quote. And I go, really? And start typing. And she's like, yeah, no, we just use double quotes if you need to use a quote. Don't worry about it. It's not a big deal, but you can't use a single quote. And I'm like, are you serious? At which point the CIO, the head of our IT division at the school, comes charging from the back saying, Matt, stop what you're doing. Don't worry about it. I need you to hold on for a couple seconds. I stop what I was doing, figure I'll wait a couple seconds. He goes back to the back of the room. It's a lab room that we're in, starts banging away on the keyboard for like 30 seconds, comes back and says, Matt, don't worry about it. Just go back to your office. If you ever need to use this reporting tool, just send us your text. You're fine. I was like, what? And he's like, yeah, you and I both know what it means when there's a single tick mark. I go, okay. And he's like, and I can read what's on your screen. So I've taken away your permission to use this app. And in fact, I made a note in your user record, that we should never give you permission for any tool on this system again. And I'm like, why? And he pointed to my screen. On my screen, I had a tick mark, a semicolon, and then I said, update table employee where username equals M Hertz, set salary equal $1 million. And he's like, trying to give yourself a raise. And I'm like, well, I was just curious what would happen. So I almost got away with it too, apparently. If it wasn't for those kids and their dog. Anyway, so anytime you see a single tick mark being banned, that means that they have this bug in it. You can take it over. So what we need to do here is change this, since this is using a search, to the parameterized version. Also has a benefit of being easier to do. So to do that, where we want the input, we have to put a question mark. And that then ends since that's the end of our SQL, we're going to end that string. And then what we have to do is provide a tuple. Remember, a tuple is basically like a list, but whereas a list is mutable, we can change its contents. A tuple is immutable. We can't. So we give the data for this tuple. We have to close the other parenthesis. And the other thing to remember when you're doing a single tuple, a one tuple, like this one, is we need that trailing comma. So now what will happen is when we do a search, we're going to send that search, our Python program will send the search to the database in two pieces. The first thing it's going to do is say, here is the SQL I want you to execute. And after that, it says, and here is the data for that query. So by separating that into two pieces, right, the SQL and the data, we don't have to worry about them trying to hack our system. It's not going to work. Instead, what will happen is we're going to search for whatever they type in, even if it would normally be a hack. So that one's okay. That one we now have fixed. So the next one here is ratings for song. So you can see again, we've got a select star from ratings, where ID, and then we have the ID in quotes. But now let's think about where this is going to be executed, right? The all songs by artist was executed when we did a search, and whatever they typed into the search, that was the value of the parameter. Ratings for song, however, is only used in get songs. It's only used internally when we're getting that big list of songs. And not only is it only used internally, but that ID is going to be some value that's already in our database. Since this isn't necessarily user input, we actually could get away with not changing that over. We don't have to change that over since there's no way that the user could attack us directly that way. We would have caught it already. Having said that, there's always the possibility something might change. Maybe we change how this is written. Maybe we change what we do in the future, where all of a sudden that ID won't just be from our database. Since there's always the possibility later on, we might want to make this the parameterized query. And honestly, that's safer and the better way of doing it anyway. I usually just do that by default. So here, even though it's not strictly necessary, I'm going to do it anyway. So now we've got that as a parameterized version. That should be okay. Here we're inserting song information into our database. So we get the song ID, the title, the artist, and then I had from before getting that query and adding the values. And again, this isn't the parameterized version. This version could be hacked. So what I'm going to do is, again, replace it with the parameterized version. There are 3 values there, so that will be our process. And then I need my tuple. And just so, well, let's do it this way. So what I can do is pass in that string and then pass in the tuple. So it's song ID, title, artist. And because this is not a 1 tuple, this is a 3 tuple, I don't need to add a comma there. I don't need to add that trailing comma. So that one's now updated. Now we have this other insert. Again, it's the unsafe version. And just so we can see what's going on, and because honestly it's easier to update a rating, what I'm going to do is, rather than just creating the tuple in the call to execute, I'm going to create it early. right? A tuple is, like I said, it's like a list. So we can assign it to a variable. We can just use that variable here. So now let's think about what's going on. Well, let's actually get it so we can see it. Let me restart my program so that we can actually take advantage of this new code. I'll have some printouts, so I want to be able to see it. So let's add a rating. So suppose I want my rating to be, the review is going to be, we'll do tick. Something like this, right? Something that could cause problems because now all of a sudden we've got all sorts of changes, or I could even just do, it doesn't really matter. It is safe, the safe version. So we'll say for this one, say it's cool. Give it a 4. So you can see it updates almost immediately. And if we look, you can see that our SQL statement, right? We've got our code, that's the SQL statement right here. Insert into ratings, values, and then the 3 question marks. Then we have that arrow because I added it so we could see where the difference was. And then we have our data. We're just going to get this tuple. Since these are going to be handled separately, this can't cause any problems in our system. So we can keep going. Again, song not added. This actually comes from our... this actually does come from our, just to show you it could happen again, data tuple equals this actually comes from our database, so we don't have to worry about it too much, but just in case, you never know. We'll make that the parameterized version. So now our program is very safe and secure. No other queries. So that takes care of anybody attacking our database. So that's one form of security. Unfortunately, there's still a problem, right? And we can actually see it if I reload. If I reload and type the comma correctly. Right, note that I've got this code here that's got that's in bold, and I can still do that. I still don't like this song. It was still way overplayed. Right, and all I'm doing is putting it in bold. That's not that big of a deal. You know, I can play around with the formatting a little bit. But of course, as we talk about in the video, as I showed in the video, as not only can we have, stuff in bold, we can actually insert anything we want, including JavaScript code that the browser would immediately execute. So this kind of attack, this is an HTML injection or cross-site scripting attack. Its problem isn't so much, that, okay, they can add a little bit of bold. It's not an attack on our server. It's actually an attack on anybody who uses this system. By using this cross-site scripting, by embedding the right JavaScript code into our page, we could actually install all sorts of software on their machine. We could make them do all sorts of actions where they don't even have control over it. So we want to prevent that. And to do that, what we have to do is prevent them from adding HTML code to our page, anything that looks like HTML. So again, in the videos, we talk about this. I talk about this a lot more, right? There are 2 ways to go about that. One option is one option that we could do would be to try to do filtering. So whenever we see something that looks like HTML, we don't allow it. The problem with filtering is it's really, really, really hard because frankly, it's a battle that we can't win. For a program like this, yeah, we could probably keep the hackers at bay. Why? Because nobody cares. Nobody's really attacking the system. On the other hand, if you work in a real system, you work for a company, you work for a bank, you work for anything where their clients, their users, whatever, have value. Could be their systems, could be the systems of their clients have value. Then the value for the hackers, the value for the people attacking those systems, is the value of all of that data that you're defending. And certainly if we're talking about users, right, injecting code into your system, that's tons, because that's every password they have, every account that they have, any systems there. So they have a lot invested in hacking. You, on the other hand, me as a developer, what do we care? Well, we have our paychecks at stake. That's important, obviously. I like getting paid, but it's not the same thing as that. It's not the same amount as the hackers have, as the people who are the black hats have. So given that sort of dichotomy, we can't make it into a game. We just have to prevent it from the very beginning. So luckily, to avoid these attacks, this cross-site scripting, HTML injection, there is support built into Python. So what we're going to need to do is import that HTML module. Luckily, that's built into, like I said, that's built into Python. We don't have to install anything. We just have to have that import HTML. And then anytime we have a string, which we're going to provide to our, over AJAX, to the browsers, to our clients, we need to make sure it's been encoded, that we change anything from what they typed in to a version that's safe for HTML. Now, there are two times that we could do this. One time we could do this is when we get in the data. So when they're giving us data to add to our system. The other place that we could do this is when we're sending data out to the clients. We can only do it in one of them because we don't want to encode our encoding. So it sort of creates a choice. The trick is this isn't actually a very good choice. If you forget, if you decide that you always want to do it when you're sending it to the client and you forget, you have no way of fixing that. You're always going to be stuck. On the other hand, if you decide to do it whenever you add data to the database, then you've always got a little bit of breathing room. If someone makes a mistake, if someone forgets as they're changing over the front end, it's not a big deal. So we always do this, or we should always do this, when we add data to our database. So what I'm going to do here is, let's see, we've got the song ID. That is a string. So what I need to do is call html.escape. Escape. Title is also a string, so I need to do that. Same thing with artist. And now I know that my songs will be safe, even if they try to provide something unsafe. We also need to do this for ratings. Actually, you can do this right here. So again, song ID. And note that the way that this escape works, if there's nothing dangerous in the actual song ID in this case, if there's nothing that will cause HTML problems, then it doesn't do anything, so it's okay. So we need to do it for song ID because song ID is a string. Rating num, based on its name, you could guess, is actually a number, right? And we know it's a number. There's no way for it not to be a number because if it is not the int 1, the int 2, the int 3, the int 4, or the int 5, then this test would fail. So not only do we not want to do it here, we couldn't. I'll just show you because I'm going to type it correctly. This is going to now crash, and it's going to crash because we can't do an escape we don't need to do an escape on a number, on an int. And in fact, we can't. It won't allow us. It doesn't work. So just to show you. And now review is also a string. It's actually where I've done these attacks. So we want to include that. And note, I'm doing all of this before I create my data tuple. So when we look at the ratings as I add them, we'll be able to see that. So you can see if I reload my page, just adding that doesn't change anything that's already in the database. Those mistakes have been made. Probably what we want to do if we're making this conversion, change over those records. Now, if I try to make a review, it's going to crash, so I'm not going to worry about it too much. Note, nothing came up, and that's because it crashed, right? What it says is it's calling this replace, which seems kind of weird until you realize it's in the HTML escape function. So it's actually in the Python code. You can see it's in this file over here. It's actually in the Python code for that HTML module. And what it says is it can't do that on an int. We can only call escape, and we only need to call escape on strings. So I can actually just get rid of this line. So now if I restart it, so it actually works. I'm just coming up with something. So I'm going to try the I element as a way of italicizing something, making something italic. So suppose I enter this. I don't know why I'm doing it in italics, but sure. I'm going to give it a rating of 4. Note that what comes back, it doesn't show it in italics. Instead, it gives me what I literally typed in. That HTML escape sort of neutralizes what we did. And the reason why, if we look at the output, is you can see that that less than sign got changed to ampersand LT semicolon. This is the way in HTML that we say show the less than sign rather than starting a new element. Then we have the I, and then we have this ampersand GT, which is how we represent the greater than sign. So what actually got added to our database was this string right here. Note that the actual review is fine, but we added not the thing that could attack our HTML, but the HTML after it's been re-encoded. And in fact, if we go back to our page, go to the networks, if we look at that rating, so in network, I should say, what I did was I clicked on the post request that we sent to rate that song, and now I'll look at its response. We can see that it responded with that exact same text. So this isn't, right? This clearly doesn't look like HTML. Instead, it's an encoded way of writing this. And so now our application is actually pretty safe. It'd be very, very hard. There's no obvious ways that someone could attack our system. So hopefully this makes sense to you all. Hopefully this gives you an idea of how you can use the secure versions of select from or select where, insert into. Again, I'll be honest with you. The only time I ever use those insecure versions is pretty much for the previous 2 lectures. I always just use the secure versions, A, because they're secure, B, that way if I want to change them, if I end up taking in user input, I don't need to make any changes, and C, they're just a lot easier to write. So if you only want to learn those, you're going to be fine. Other thing to remember, if we're working in Python with user input that is going to be sent to a web page, we want to call HTML escape on it. We want to make sure that it's going to work correctly. So given that, does anybody have any questions for me? Anything about how we've made this changeover, how it all works? Okay, I don't see any changes or any questions. So, yeah, yes, you have questions. You don't have questions. Uh, so question about Lab 7, not right at the moment because there are still students, I think, taking Lab 7 right now. They might still not have started. If you want, go to Piazza, and right after this ends, I can answer it there. Does that work? Well, hopefully they have now heard that. So with that, I'll go over to Piazza to answer the student's question. Thank you all. Have a good weekend. Stay safe. Stay secure. We're going to be talking about some fun stuff next week. Encryption, hashing, stuff like that. Thank you all. Have a good weekend. Have a little bit of fun. Stay safe and secure and healthy. Bye.